In this video, we're going to look at solving some basic one-step equations and two-step equations, and we'll increase the difficulty as we go along, and we'll eventually get to solving multi-step equations. Okay, so in number one, we have x plus 4 equals 10. Okay, now this is called a one-step equation because after one step we have solved for x already. Okay, so when you're solving this equation, what you're really looking at is what number plus 4 gives you 10. And that's something that most people can do in their head. They can say, I know that 6 plus 4 gives us 10, so I know that the x value must equal positive 6. Okay, and it's all fine and dandy to do that in your head and figure it out that way. Okay, but the idea is the more complicated the equations get, and maybe the larger numbers, maybe negative numbers will start giving you trouble. We need an algebraic way to solve equations. Okay, so we know that x equals 6 because 6 plus 4 gives us 10, but the algebraic way to find x equals 6 would be doing the opposite operation as adding 4. Okay, so to undo adding 4, okay, now mathematically it's going to be called the inverse of adding 4. Okay, so how do you undo adding 4? Is adding a negative 4 or subtracting 4 from each side. Okay, so this is probably what you're used to, is saying minus 4 on each side, because whatever you do to one side of the equation, you have to do to the other. And 10 minus 4 gives us 6. The 4 minus 4, they go to 0. Okay, so we end up with x equals 6. In number 2, we look at that and say negative 2 times what number will give us 16? Well, if you do a 2 times 8, that gives you 16. So how do you get negative 2 times what gives you positive 16? Again, most people can think their way through that and say x equals negative 8, because negative 2 times negative 8 gives you positive 16. The algebraic way to find that is to do the opposite operation as multiplying by negative 2. To undo that, we divide each side by negative 2. So there, negative 2x divided by negative 2, the negative 2 is reduced to 1. So you're left with x equals 16 over negative 2 is negative 8. In number 3, we have x divided by 3. So what number divided by 3 gives you 5? Okay, again, many people can do that in their head and say x equals 15, because 15 divided by 3 gives you 5. Okay, the algebraic way to do that, to undo, or the opposite operation of dividing by 3, is multiplying each side by 3 over 1. So the 3's reduce out to 1 here, so x equals 5 times 3 is 15. Okay, and those are basic one-step equations, because you do one step and you're done. Okay, we look at some two-step equations, like 2x minus 3 equals 15. Now here, we have to get x by itself. If you're going to think your way through this question, we're saying, all right, what number can you multiply by 2 and then subtract 3 to give you 15? Well, that's a little harder to think about in your head. Now, some people can do that, okay, but it's a little more complicated than the first 3 questions up here. Okay, so one way to look at it is kind of reduce it down to a one-step equation. So let's think about this. If I were to cover up the 2x, what minus 3 gives you 15? Well, most people can do that in their head and say 18. If you do 18, subtract 3, that'll give you 15. So that means that whatever is under my finger here must be equal to 18. Well, what's under my finger? 2x. So we know that 2x must equal 18. Now, the algebraic way to get that would be to do like we did in the first 3 examples of adding 3 to each side. So if you add 3 to each side, 15 and 3 gives you 18, and then just bring down the 2x. So now 2 times what gives us 18? Well, if we divide each side by 2, or do it in our head, we know that x will equal 9. So we see that 2 times 9 is 18, subtract 3 gives us 15. Okay, now the point I want to make there is that when you solve an equation like this, it's more than one step. Okay, notice how the algebraic steps we took was we undid the subtracting 3 before we undid the multiplying by 2. Okay, so we added 3 before we did the dividing by 2. Okay, and that's important. Okay, basically it's reverse order of operations, or reverse PEMDAS. Okay, the next one, keeping that in mind, we subtract 4 from each side. So 2/3 x equals, well, -5 subtract 4. If you need to do that in your calculator, do it. It'll give you -9. And then to undo multiplying by 2/3, you can do 2 things. You can look at it as divide by 2/3. Just make sure you put 2/3 in parentheses. Okay, so if you do -9, okay, in our calculator, -9 divide by parentheses 2/3. Okay, that gives us -13.5. Now I'm just going to do the arrow button here to make it into a fraction of -27/2. Okay, so x equals -27/2. The other way to deal with a fraction is to multiply by the reciprocal. So if you had this equation, 2/3 x equals -9, the reciprocal of 2/3 is 3/2. So if you multiply by 3/2, notice the 2's reduce out, the 3's reduce out to 1x equals, and then whatever you did to one side, you do to the other side. Well, -9 is like -9/1. So then you use straight across, -9 times 3 is -27. 1 times 2 is 2. So you still get -27/2. Okay, so when you're dealing with multiplying by a fraction, the opposite operation, you can divide by that fraction or multiply by the reciprocal, okay, meaning flip the fraction. Okay, whichever you're more comfortable with is up to you. Okay, the only thing you have to be careful of, in your calculator, when you divide by the fraction, you need to make sure that you put the fraction in parentheses. Okay, number 6. Okay, on this one, we have -1/2 x plus 3 equals -6. So we'll undo adding 3 by subtracting 3. So -1/2 x equals -9. And then to get rid of multiplying by -1/2, okay, we can multiply by -2/1. Okay, and that'll give us x equals 18. Okay, moving along here, look at a couple more equations here that are a little more complicated. So now just suppose we kick it up a notch and say, all right, we have x in more than one spot now. So 2x minus 5 plus 4x equals 13. Okay, notice how x's are on the same side of the equal sign. So what we don't do is we don't say like minus 2x because they're on the same side of the equal sign. Here, we're looking at the left-hand side of the equals and combine like terms together. Well, 2x plus 4x gives you 6x. So when you combine these x's together, okay, we get 6x. Bring down the minus 5 equals 13. And then this equation is really the same thing as the few up here, like 2x minus 3 equals 15. Okay, now it's that basic form of the equation. Okay, so here, to get rid of minus 5, we'll add 5 to each side. So 6x equals 18. Divide by the 6. So x equals 3. Okay, question number 8. Again, we look at the left hand of the equal sign and the left-hand side of the equation. We have a negative x and a negative 2x. So combine those together. Remember, negative x is like negative 1x. Subtract 2x. Putting those together, we get negative 3x. I'll bring down the plus 6 on the left-hand side, equals negative 8 plus 12. We can add those together to get positive 4. Okay, then if we subtract 6 from each side, and notice that that equation, again, is the same form as the two-step equations from like 4, 5, and 6. Okay, same idea. Subtract 6 from each side. We get negative 3x equals 4 take away 6 is negative 2. Okay, and please don't miss this because you're trying to do it in your head and you make silly mistakes. I would suggest trying it in your head and then using your calculator to check to make sure you're right. And then negative 3 times x equals negative 2. Divide each side by negative 3. The negative 3's reduce out. We get x equals to 1. X equals negative 2 over negative 3. We can simplify that to 2/3. Okay, and we will write our answers as fractions. Okay, if we get a decimal, we're going to write them as fractions. Okay, so let's move on to some more complicated ones. So here, we ended with having x on the same side of the equation. Well, now what affects on opposite sides? Okay, so let's take number 1 here. 3x minus 7 equals 2x plus 1. So now that the x's are on opposite sides, we need to combine them together. We can't just say, though, like we did before, like 3x plus 2x, because they're on opposite sides of the equal sign. So in order to put the x's together, we have to undo the 2x on the right-hand side and move it to the left-hand side. Okay, so that's one way we can start this, is by subtracting 2x from each side. And what that does is 2x minus 2x, that goes to 0, and you can bring down the positive 1. And then on the left-hand side, 3x take away 2x is 1x. I'll bring down the minus 7. Now we could have started off by subtracting 3x on each side. Then we just have 2x minus 3x over here. We'd have negative 1x on this side plus 1. And then just negative 7 on the left-hand side. You will get the same answer as long as you do the steps correctly and the algebra correctly. You'll get the same answer. Okay, but I always find it easier to keep the x's positive if you can. Okay, you always want to make your x happy, right? Keep them positive. All right, so 3x minus 2x. Actually, we don't care about our x's, do we? Okay, 3x minus 2x will give you 1x. Okay, so that's a positive 1x. So then to solve that, you just add 7 each side. So x equals 8. Okay, and there's your answer. Move along to number 2. Okay, here we have parentheses involved. Okay, so that is the distributive property, which says you distribute that 2 to each of the terms in the parentheses. 2 times 3x is 6x. 2 times negative 5, and pay attention to signs here, 2 times negative 5 gives you negative 10. Okay, so 6x minus 10. Subtract 6 equals, well, 20 plus 4x. We cannot actually combine those together because they're not like terms. So it's just 20 plus 4x. Okay, now this equation is pretty close to the same idea as over here with x's on each side. So we can do a couple steps at once here. I am going to bring this 4x to the other side by subtracting 4x. So I'm going to combine the x's together on one side. And I'm also going to do negative 10 minus 6 all at once. Okay, so we'll combine those together because they're on the same side. So 6x minus 4x gives you 2x. The negative 10 minus 6 gives you negative 16, and then equals 20. Then if we add 16 to each side, we have 2x equals 36. Divide by the 2, and we end up with x equals 18. Okay, a couple more examples. In number 3 here, we have 5 minus 3 times the quantity x plus 5 equals negative 2 times the quantity 4x minus 1. Okay, so a very big mistake that people make, a lot of students make on this, they'll do 5 minus 3 is 2, and then go from there. The problem with that is that we're looking at 3 times something here. Well, when you have subtraction and multiplication in the same problem, don't you do the multiplication first before you do the subtraction? So we have to do the 3 or negative 3 times the x plus 5 first before you do 5 minus anything. Okay, so the way I look at this, I treat that as negative 3 times x plus 5. So I'm going to bring down the 5 because I didn't do anything with that. Negative 3 times x is negative 3x. Negative 3 times 5 is negative 15. And then on the other side, negative 2 times 4x is negative 8x. Negative 2 times negative 1 is positive 2. Okay, again, people doing 5 minus 3 to get 2 first is a very common mistake, and it's a very big mistake to make. Okay, so now, on the right-hand side, there's nothing we can combine together because negative 8x and 2 are not like terms. On the left-hand side, we have a 5 minus 15. So putting 5 minus 15 together, that's a negative 10. We can bring down minus 3x, and we can either put negative 3x in front of the minus 10 or after the minus 10. It really doesn't matter. Okay, just up to you. And now if we combine the x's together, if I add 8x to each side, I'm kind of thinking ahead a little, recognizing that if I do negative 3x plus 8x, I'm going to end up with a positive value. Okay, so negative 10 plus 5x equals 2. Now I get rid of the negative 10 by adding 10 to each side. So 5x equals 12, and then divide by the 5. So x equals 12/5. Okay, if you do that division in your calculator, it'll give you 2.4, but turn it into a fraction of 12/5. Okay, I'm not going to say I'm going to mark 2.4 wrong, but it just depends on the fraction that you get. Like if that was like 12/7, just say for example 12/7, then you're going to get some kind of decimal value that you'd have to round. Okay, and we don't want to see any rounding. We want to have the exact answer. Okay, then finally the toughest one, or the toughest type I give you. Okay, we have parentheses in a couple places. We have x's in several places. Okay, so we have to look at order of operations. Okay, just like the last one, we can't actually do 4x minus 5. First of all, because we have subtraction and multiplication. And second of all, 4x and 5 are not even like terms. Okay, so you take negative 5, distribute it to the parentheses. So bring down the 4x. Negative 5 times 2x is negative 10x. Negative 5 times negative 3 is positive 15. And then on the right-hand side, distribute the 4 to the parentheses. That'll be 8. And then 4 times negative 1x will give you negative 4x. And then just bring down the plus 3. Now notice that plus 3 is not in the parentheses, so you're not doing 4 times 3 is 12, because 3 is outside of the parentheses. Okay, now if we combine like terms on each side of the equation, the 4x minus 10x, that'll give you negative 6x. I'll bring down the plus 15 equals. On the right-hand side, we can do 8 and add 3 to get 11, and then minus 4x. Okay, now here, if we put the x's together, we can either add 6x to each side or add 4x to each side. Now I'm going to look at adding 6x to each side because if I do that, notice that'll give me positive 2x over here. So 15 equals 11 plus 2x. And then to solve that, we'll subtract 11. So 4 equals 2x. Divide each side by 2. Oops. So x equals 2. Okay, so that's solving several equations, starting with one-step equations and working your way up to more complicated equations. I won't give you, in this class, I won't give you any that are more complicated than number 4. Now, you may get like a fraction at the end for an answer, but as far as the steps to take, nothing too much crazier than that.